Hello, everyone. Welcome to another episode of the Blasphemy Bite. Today's topic is recursion, and the example that we're going to look at today is very common, has been described in detail in a lot of places, on YouTube, everywhere. Like, it's a very common problem, and the reason why I'd like to do it is because I like the problem. It's the Tower of Hanoi problem. The reason why I like it so much is the minute I recognize that, oh wow, this is a recursion problem where I really have to believe what my recursive function is doing. If I don't believe it, then it's not going to work. And that kind of realization is what made me feel like, oh, okay, let's teach this to the world, or use my way of teaching this to the world. There's a very good video of, I'm not sure if it was a Harvard or a Stanford professor teaching this problem, and she did an amazing job of it. You all have to look at it. I'll put a link in the description. Anyway, the Tower of Hanoi question goes like this. You are given n number of pegs to, let's say in our case it's 3, and you're given weighted plates. And the plate with the lowest weight has to go at the bottom. That's just how we write our code, how the question is. And the one second highest, and then the third highest. I'm just using different colors because my lines are not good, I've realized. It's really not good. I tried doing it with all black and just fucked everything up. So let me just keep everything open, right? Don't want to waste everyone's time. I mean, my hand's going to get a little messy, but it's still my channel, watching this video, so let's keep going. Now, the whole idea is that you have to go from your source, which is here, and you have to move all of these guys to the destination. And the problem is that you cannot put a plate which is heavier on top of a lighter plate. So for example, you removed this guy from here and you put it here, okay? You are not in any way allowed to put this here, okay? That just violates everything. Like, the whole basis of life just goes for a toss, and you don't want to fucking mess with that, right? The whole balance of life, I mean, we get a whole movie about balance, right? So we don't want to break the balance, we want to keep the balance. And for that reason, we're not going to use, we're not going to keep stack items that are heavier on top of something that's lighter. Now you're allowed to use this extra peg that's used for, I mean, obviously if you didn't have that extra one, you would not be able to finish this problem. Now, what if you had another one? Well, you would do it and make your life even easier, right? And then the reason why this would be interesting is you just have one spot to move every time. So every time you have to move one and put another place, move one, put another place. Now let's try to manually do this, right? Hopefully it should be a little straightforward. So we had our smallest guy sitting here, and then we moved somebody heavier over here, and then what did we do? Let's move this guy here so that this guy can come out. So let's take that guy out and put him here. And then what can we do? Why don't we just put this guy back here, and then the red can go on top of this guy, and then you can move the green from there and put it back on top, and there you have it. And then what do? You made that guy empty, right? Like he's free to go to a destination. So finally what do? We can move him to the destination. Okay, and then you do something similar, and then you get and then you're able to move all of these guys also to the destination. But if you notice, this is not as simple or straightforward if you were doing it manually, right? And since we have a computer that can do all of the computation for us, why even bother? Now let's look at how we would do this using a recursion. The way we would do it is you take all of these and I think it's blue, red, and green. Okay, now assume, okay, you have a function, you have a beautiful function, nice base cases and nice functions doing something where you can take the top part, all these three guys, and place it in your, so this is SRC, DST, and you have your, I'm going to call it the auxiliary part. Let's say that you had a function which could move this and then place it over here. Okay, so you take all of this thing and place it there. Okay, so you would get red and green. Okay, and then all of this is gone. Okay, so what did you do? And then you go and move it here. Okay, and then what you do is you take the top half of this guy, take the top half of that guy, and then move it somewhere, move it here, so that you can take him and put it there. Okay, now let's do that. So somehow, I don't know how, I mean I know how because I've seen the solution, but let's say I don't know how. Okay, so now you free that guy up, so you can put that guy over here. Okay, finally take this top part and place him here, right? And what does that leave us with? That leaves us with this guy who can now go and sit on top over here, right? And then finally what do we have? We have the green guy. I'm going to take the green guy and then put it in at the very top. So voila, we have done Tower of Hanoi. That is pretty cool. Now let's look at some of the code for this problem. Okay, well, the code is very simple. What we are going to do is, if we're going to have 3 stacks, okay, 1 stack for the source, 1 stack for the auxiliary, and 1 stack for the destination. At every point in the stack, we'll have the values or the number of rings that are going to be there in that. So when you're starting off, your source stack will have how many? Will have 4 values, and your auxiliary and your destination will have 0. Okay, And every time you move, you're going to keep changing one guy from the source stack to the destination stack. Okay, and now let's look at the code. So one thing that we have that I might have forgotten to mention is that you're taking n minus 1 number of rings, okay, taking it from the source, like wherever we started from, so it was the source, and then we're going to put it in the auxiliary, right? Now where is all of these guys? They're all residing here. And then once you move this guy, so what are we going to do? We're going to do a stack dot top and then we're going to stack dot push into the destination T, and then we're going to do stack of source dot pop. Okay, so that way whatever was here, it's gone, and put it back. And after you're done with that thing, right, you need to put that guy back where he was, right? You have to, you did that part, and then you still need to do the part of putting him, all of those guys over here. So what are we going to do? We're going to do all of those n minus 1 rings. Where are they right now? They are right now at the auxiliary, right? Now take them from the auxiliary and put them into the destination. Okay. Why did I write all destination? I don't know, because it's late and I'm sleepy. Now the important thing to note here is the part where we're taking n minus 1 nodes or rings and taking it from the source and then moving to the auxiliary, and then we do some operation where we move the last ring, the heaviest ring, the fattest ring, and move it to the destination, and then we go back and take those rings that were lighter than the fattest ring, and then move it also to the destination. Now your recursion is going to end when your n value is equal to 0. So basically you would say if n equal to 0, then just return, don't do anything, right? Because there's nothing to do. Else what are we going to do? We're going to call our helper function, and we're going to pass some things. One would be the stacks. Now I'm not going to go into the implementation. I'm going to put up the source code. It's actually from API and it works beautifully. You can try that out. So all of the stacks, the source stack, the auxiliary stack, and the destination stack. And then what we're going to do is we're going to mention what's our source, auxiliary, and destination. So in this case, I'm going to call my source is 0, auxiliary is 1, destination is 2, 0, we want to reach 1, 2. Okay, and the number of rings at this point of time is going to be n minus 1, because we want to go into the next stage, right? So we take all of those n minus 1, all of those guys, and move it to another one, okay? And then once you're done with that, what do we want to do? We want to take the source, so stack of 0, so let's call this as, yeah, so our function would have had stacks, and it would have int say int destination, int auxiliary, and int rings. Okay, and all of those would come here. So in the helper function, what do you want to do? You want to take stacks, and then we want to take the guys who are in the source, right? Source, and move it into the aux. Okay, and then we will use destination as the auxiliary here. Okay, and then once you have that at the end, at your source stack, so stack of source dot stack dot top, and then stack of, in our case, destination is tst dot push t, and then finally you pop the item out of the source stack. Okay, and that's basically your code, man. There's nothing else happening in your code. Now the extra part would be to find out how do you actually know the path that you're taking. So what do you have to store? So every time you do this stack change thing, you have to save the source and the destination into another data structure, just to keep track of it. Okay. Now the last thing we're going to do is, like, how does this actually work in the code, right? I mean, yeah, sure, I told you guys that it works, but how does it actually work in the in code? So we're just going to draw the diagram for this. The last bit, we're just going to see whether this actually works, right? I know it works, but we're going to take n is equal to 3 and see how far or how this code execution works. So just remember the how we were using the code. Like, the helper function gives us source, destination, auxiliary, and then what we have to do is take n minus 1 from the source, put it into the auxiliary that we got from there. Okay, and then do your stack operation, and then you basically take all of the things that you have in the auxiliary and put it also into the destination. Okay, so when you're originally calling the function, you need to call it with the source, right? The source, the destination, the auxiliary, and the number of rings. Okay, and then once you call this guy, he is going to call number 1. He's going to call, you want to move n minus 1, that's 2 rings, from the source to the auxiliary, right? So what we're going to do here is still the source, take it to the auxiliary, and use the third, use the destination as an auxiliary, and you're going to do two rings. Okay, and then you're going to do, we'll go down the stack trace, but in between there's the stack operation happening, right? So I'm just going to call it an op, and then finally you have here, you want to take all those things that are in the auxiliary and put it to the destination, right? So you would have, where is it right now? It's in 2, right? You want to move it to 3, and then 1, and then you still have 2 elements. Okay, so when you come here, what do we get? We want to move the things that are in the source and move it to the auxiliary, right? But in our case, what will our auxiliary be? So we're going to do 1, and our auxiliary is now, and our destination is now 3, and our auxiliary is 2, and then we just do 1. okay, and then you do your stack operation, and then you come back and take all the things that you put in your auxiliary, which is now at 3, put it into the destination, and then you finally use that. Okay, similarly you have operations here where you take things that are in the source, put it into the auxiliary and use the destination, and then you have just one, and then you do the stack operation, and then finally you move the things that you kept in the auxiliary, which is in 1, put it into this the destination, which is 3, and use 2 as an auxiliary. Okay, finally you come down here. You come down here, you have to move from 3 to 1 and use 2, and then you have 0, and then you do the stack operation, and then you have 1, 2, 3 and 0. Now, if you noticed, you don't have to do these operations, right? Because our operation, our terminating condition was that if the number of rings is 0, then you don't do it, right? So then you just do the stack operation and then move on. Similarly here, you just do the stack operation, just do the stack operation, you do the stack operation, you do the stack operation. Okay. Now when you're going through the code, what do you think gets executed first? First thing that gets executed would be this stack operation, right? So in this stack operation, what is going to happen? Let's actually draw. So what I'm going to do is, I have a current status here, the next status here, and then keep flip-flopping. This is a good way of, if you're into embedded systems, you could wear out the flash, or you could say that's the hard drive of the system. If you keep reading the same location, so let's say you have a value that keeps getting written to, and you're using the same memory location every time to save that, and you're saying, let's say you're doing 1,000,000 reads and writes. Reads are okay, but if it's a write and you're changing values, then you have the possibility of burning that out. Trying to do that, something that I don't want to keep rubbing off here and then doing the same thing again, so I'm just flip-flopping. Okay, let's go 1, 2, 3, 4. Okay, in the first thing, what's going to happen? Okay, we're just going to do 3, right? 1, 2, 3. We come all the way down here, and what are we going to do? We're going to take something from, let me just verify that that's all correct. 1, 3, 2, 3, 1, 2, 3, 2, 2, 3, 1, 2. Okay, looks like the values are all correct. So let's start. What is our stack operation going to do? It's going to take something from the source, put it into the destination. So what do we have there? We have the smallest guy sitting over there. So we've done that guy. Now in the second operation, we'll come back here. We come back here, right? And there, what's the value? The value is we'll take one guy from there, okay, and put it in the middle. Okay, so that's done. And then you come here, and what does he tell us to do? It's telling us to take 3, put it into 2. So what do we get? Okay, so we have completed that, and then we come back, we're going to do this. What's it telling us to do? Take one guy from this stack and then put him in the larger one, put him in the last one. So you're done with that. And then you come here, telling you to take something from 2, put it in 1. So what we're going to do, we're going to put the small guy there, and we're done with that. Come back here. What does it tell us to do? Take number 2, put it into the last one. So you get 3. And then we're done with that. Finally, we come here, tell us to take number 1, put it into 3. Right? There we go. You did 1, 2, 3, 4, 5, 6, 7 operations to come to the solution. I'll put a small summary of the time complexity. So you had 3 rings, and your value came up to be 2 raised to 3 minus 1, 7. Okay, so the order comes to 2 raised to n minus 1. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, and that's basically it. And it was a long session, but it's definitely worth it. Tower Hanoi looks very simple. There are a lot of variations to this problem, and if I have time, I might do some follow-up problems as well. But thank you for listening, and have a good day. Hey everyone, if you like the video, please make sure to like, subscribe and share. There's also a GoFundMe page where you can go and fund my wife's dental school, and I would like it if you would donate anything. $1 would be fine. Thank you.